Hello, this is a lesson on temperature. Another lesson that follows this one will be on a lesson on heat. So first of all, let's begin with a quick joke. So there's this patient in the room and doctor's looking at his charts and he asks the nurse, "Nurse, did you take his temperature?" And the nurse says, "No, why? Is it gone?" Well, it's important to note that temperature is a measurement of the average kinetic energy of molecules of a substance. And the units for temperature we use in chemistry and physics are called the Kelvin. Notice it doesn't have a degrees attached. We can also use degrees Fahrenheit and degrees Celsius, but in chemistry and physics we use kelvins. The reason Kelvin units are used, besides units of Fahrenheit or Celsius, is because Kelvin is an absolute scale, which means that there is no lower temperature on it than zero, and the only way to get to zero, called absolute zero, is to make the molecules stop moving. So when we do the math and our formulas for chemistry and physics, if we put 0 degrees Celsius, which is a very common temperature, as a matter of fact it's standard temperature, which you'll learn later, 0 degrees Celsius, the freezing point of water, if we put 0 in our formulas, then all our answers would either come out undefined or they'd come out 0, depending if you're trying to multiply by that temperature or divide by it. So on the Celsius scale, 0 degrees Celsius, which is the freezing point of water, converts into 273 Kelvin units. That's because at absolute zero, where the molecules have totally stopped moving, the temperature in degrees Celsius is minus 273 degrees Celsius. So there's a simple conversion to convert between Celsius and Kelvin, or Kelvin and Celsius. So let's look more carefully at the Kelvin scale and the Celsius scale. First of all, Kelvin, there is no negative numbers. It's an absolute scale. The coldest it gets is when molecules have stopped moving. That's called 0 Kelvin. That's absolute zero. And 0 Kelvin is very, very cold. It's so cold that the Celsius temperature is negative 273 degrees Celsius. So if you wanted to convert between Celsius and Kelvin, you just add or subtract this number, 273. Now, how do you know which way to do it? How do you know when to add? How do you know when to subtract? So let's take a common temperature and we use in physics and chemistry, the freezing point of water, 0 degrees Celsius. Now clearly we can't use that number because 0 multiplied by anything is 0, and of course you can't divide by this temperature because you can't divide by 0. So we clearly see we can't use the Celsius temperature scale for the fact that it has 0 in it. But 0 Celsius is equal to 273 Kelvin. So 0 degrees Celsius is equal to 273 Kelvin. Notice that's a positive 273. Over here it's negative. So that tells you when you're adding or subtracting. When you're going from degrees Celsius to Kelvin, what do? You add 273. And when you're going from Kelvin to degrees Celsius, you subtract 273. Alright, so that's how you convert between Celsius and Kelvin. Let's do one quick one. Let's take boiling point of water. On the Celsius scale, the boiling point of water is 100 degrees Celsius. That means there's 100 units between the boiling point and the freezing point of the water. That's how Anders Celsius made his scale. He got water cold and froze it, called that 0. Then he heated the water up to boiling, called that 100, and that's his temperature scale. He made equal units above and below each one of those degrees above 100 and each one of those below 0, and he kept going. Well, it only goes down to negative 273. Okay, So 100 degrees Celsius, if we're trying to convert it to Kelvin, we're going to add 273 to it. So 100 degrees Celsius is 373 Kelvin. Okay, let's do another one. Let's do 20 degrees Celsius. 20 degrees Celsius plus 273 for the Kelvin, and we get 293 Kelvin. So it should be easy enough to convert on your Celsius thermometer in a lab between Celsius and into Kelvin. And another important aspect of the Kelvin temperature is that it's directly proportional to the average kinetic energy of a sample of gas molecules. So an increase in 1 degree Celsius is equal to an increase in 1 Kelvin unit. And we've also mentioned that the Kelvin temperature scale does not have any negative units, so degrees aren't used for Kelvin. You just say units Kelvin rather than degrees Kelvin. So we remember that temperature is a measurement of the average kinetic energy of molecules in a substance. And kinetic energy, if you remember from your 8th grade physical science, kinetic energy is equal to 1/2 the mass velocity squared. So the kinetic energy of these molecules is 1/2 their mass times their velocity squared. So they all have the same mass because they're all oxygen in this case, and they all have different velocities, obviously. Here on the x-axis we can see the velocity in meters per second. If you look under the red curve, you can see that this temperature is negative 100 degrees Celsius, so that means that the average molecules under this red curve have that temperature, have that kinetic energy that would translate to 100 degrees negative on the Celsius scale. As we follow the curve to the highest velocity it gets here, over 800, see hardly any molecules under that curve are moving that fast, but still there are some moving much faster than the middle average area. And then also down here into the red curve, you can see that not too many molecules are near absolute zero. None of them are at it at all, but some of them are moving pretty darn slow. But still the average translates back to this negative 100 degrees Celsius. When you heat the molecules up a little more, their mass hasn't changed, but what has changed? Their speed, their velocity. They've sped up. You can see a lot more in this average area here under the curve are moving 300 meters per second. And very few are moving over 1,000 meters per second, and very few are moving, down here, at 20 meters per second, let's say, or somewhere around there. And then when we heat it up to 600 degrees Kelvin, or Celsius, sorry, that'd be 873 Kelvin. We can see that the average in here is around 700 meters per second, but still some are moving much faster than 1400 meters per second, and some are moving very slow, under 100 meters per second. But the average kinetic energy, and remember it's their velocity we're looking at, is right here in this 700 meter per second range. So that's just a graph that kind of shows you how temperature is a average kinetic energy reading of the molecules in a substance.